Installing ground fault circuit interrupters, or GFCIs, throughout a home, with the exception of the refrigerator circuit, is a generally sound practice offering multiple advantages. Firstly, enhanced safety is a paramount benefit. GFCIs are designed to detect imbalances in electrical current, which could indicate a ground fault. When such an imbalance is detected, the GFCI rapidly trips the circuit, interrupting the flow of electricity. This action is crucial in preventing electrical shocks and electrocution, safeguarding individuals from potentially life-threatening injuries. Secondly, adherence to building codes is another significant advantage. Many modern building codes mandate the installation of GFCIs in specific areas prone to moisture or water exposure, such as bathrooms, kitchens, laundry rooms, and outdoor outlets. By installing GFCIs in these areas, one ensures compliance with safety regulations, mitigating the risk of code violations and promoting a safer living environment. Thirdly, appliance protection is an often overlooked benefit of GFCIs. These devices not only protect people but also safeguard sensitive electronic equipment from power surges and electrical faults. Power surges, which are sudden spikes in voltage, can damage or destroy electronic components. GFCIs act as a barrier, preventing these surges from reaching connected appliances and minimizing the risk of damage. Fourthly, a sense of security arises from knowing that GFCIs are in place. The awareness that these protective devices are installed throughout the home provides peace of mind, ensuring that family members and valuable appliances are shielded from electrical hazards. This feeling of security contributes to a more comfortable and relaxed home environment. Now, let's address the exception regarding refrigerators. Refrigerators present a unique challenge when it comes to GFCI protection. These appliances often have compressor motors that draw a substantial amount of current during startup. This inrush of current can sometimes trigger a GFCI, causing it to trip unnecessarily. Such nuisance tripping can disrupt the operation of the refrigerator, leading to food spoilage and inconvenience. Therefore, it is generally advised to connect refrigerators to a dedicated circuit equipped with a standard circuit breaker rather than a GFCI outlet. This ensures a stable power supply for the refrigerator while maintaining electrical safety in other areas of the home. To delve deeper into the technical aspects of GFCIs, it is important to understand how they function. A GFCI constantly monitors the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through these two wires should be equal. However, if a ground fault occurs, such as when a person touches a live wire, some of the current will divert to ground, creating an imbalance. The GFCI detects this imbalance and trips the circuit within milliseconds, preventing a dangerous electrical shock. The sensitivity of a GFCI is typically set to trip when the current imbalance reaches 5 mA or 5 amps, which is a level that is considered safe for humans. When installing GFCIs, it is essential to follow the manufacturer's instructions and local electrical codes. Proper wiring is crucial to ensure that the GFCI functions correctly. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the GFCIs for you. Additionally, it is important to test GFCIs regularly to ensure that they are functioning properly. Most GFCIs have a test button that simulates a ground fault. When the test button is pressed, the GFCI should trip, indicating that it is working correctly. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to protecting against electrical shocks, GFCIs can also help to prevent electrical fires. Ground faults can cause wires to overheat, which can ignite nearby flammable materials. By tripping the circuit when a ground fault occurs, GFCIs can prevent this overheating and reduce the risk of fire. Furthermore, it is important to distinguish between GFCIs and arc fault circuit interrupters, or GFCIs. While both devices protect against electrical hazards, they do so in different ways. GFCIs protect against ground faults, while GFCIs protect against arc faults. Arc faults are dangerous electrical arcs that can occur when wires are damaged or connections are loose. These arcs can generate heat and ignite nearby materials, leading to a fire. GFCIs are typically installed in bedrooms and other areas where arc faults are more likely to occur. In summary, installing GFCIs throughout a home, with the exception of the refrigerator circuit, offers numerous benefits, including increased safety, code compliance, appliance protection, and peace of mind. GFCIs protect against electrical shocks and fires by detecting imbalances in current and tripping the circuit when a fault occurs. When installing GFCIs, it is important to follow the manufacturer's instructions and local electrical codes. Additionally, GFCIs should be tested regularly to ensure that they are functioning properly. While GFCIs are an important safety device, they are not a substitute for safe electrical practices. It is still important to avoid contact with live wires and to use caution when working with electricity. Now, let's consider some specific scenarios where GFCIs are particularly beneficial. For example, in bathrooms where water is prevalent, the risk of electrical shock is higher. GFCIs can protect against shocks from faulty hair dryers, curling irons, and other electrical appliances. Similarly, in kitchens, where there are often wet surfaces and electrical appliances in close proximity, GFCIs can provide an extra layer of protection. Outdoor outlets are also particularly vulnerable to moisture and water exposure. GFCIs can protect against shocks from power tools, lawn equipment, and other outdoor electrical devices. In addition to these common areas, GFCIs can also be beneficial in other areas of the home, such as laundry rooms, basements, and garages. In these areas, there may be a higher risk of moisture or water exposure, or there may be more opportunities for electrical faults to occur. When choosing GFCIs, it is important to select models that are rated for the intended use. For example, GFCIs that are installed outdoors should be rated for outdoor use and should be protected from the elements. Additionally, it is important to choose GFCIs that are compatible with the existing wiring in the home. Different types of GFCIs are available, such as receptacle GFCIs, which replace existing outlets, and circuit breaker GFCIs, which replace existing circuit breakers. When replacing an existing outlet with a GFCI receptacle, it is important to ensure that the wiring is properly connected. The GFCI receptacle will have terminals for the hot, neutral, and ground wires. It is important to connect the wires to the correct terminals to ensure that the GFCI functions properly. If you are not sure how to connect the wires, it is best to consult a qualified electrician. When replacing an existing circuit breaker with a GFCI circuit breaker, it is important to turn off the power to the circuit before removing the old breaker. The GFCI circuit breaker will have terminals for the hot, neutral, and ground wires. It is important to connect the wires to the correct terminals to ensure that the GFCI functions properly. If you are not sure how to connect the wires, it is best to consult a qualified electrician. After installing a GFCI, it is important to test it to ensure that it is functioning properly. To test a GFCI, press the test button on the device. The GFCI should trip, indicating that it is working correctly. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCIs are an important safety device that can protect against electrical shocks and fires. By installing GFCIs throughout a home, with the exception of the refrigerator circuit, individuals can create a safer living environment for themselves and their families. Remember to consult with a qualified electrician if you have any questions about installing or testing GFCIs. To reiterate, the primary function of a GFCI is to protect people from electrical shock. It does this by monitoring the current flowing in a circuit and quickly interrupting the power if it detects a ground fault. A ground fault occurs when electricity takes an unintended path to ground, such as through a person's body. The speed at which a GFCI trips is crucial. It typically trips within 1/40th of a second, which is fast enough to prevent serious injury or death. The National Electrical Code, or NEC, outlines the requirements for GFCI protection in various locations. Article 210.8 of the NEC specifies where GFCI protection is required in dwelling units. These locations include bathrooms, garages, outdoor locations, crawl spaces, unfinished basements, kitchens, and laundry areas. The specific requirements may vary depending on the edition of the NEC that is in effect in a particular jurisdiction. It is important to consult the local electrical codes to ensure compliance. While GFCIs are highly effective at preventing electrical shock, they do not protect against overloads or short circuits. Overloads occur when too much current is flowing through a circuit, while short circuits occur when there is a direct connection between two conductors. Circuit breakers and fuses are designed to protect against overloads and short circuits. Circuit breakers are reusable devices that trip when an overload or short circuit occurs. Fuses are one-time use devices that melt and break the circuit when an overload or short circuit occurs. It is important to use the correct size circuit breaker or fuse for a particular circuit to ensure proper protection. The size of the circuit breaker or fuse is determined by the ampacity of the wires in the circuit. The ampacity is the maximum amount of current that a wire can safely carry. The NEC provides tables that list the ampacities of different types of wires. It is important to select a circuit breaker or fuse that is rated for the ampacity of the wires in the circuit. Using a circuit breaker or fuse that is too large can allow too much current to flow through the wires, which can cause them to overheat and potentially start a fire. In addition to GFCIs, circuit breakers, and fuses, there are other electrical safety devices that can be used in a home. Surge protectors are designed to protect electronic equipment from power surges. Power surges can damage or destroy electronic components. Surge protectors typically have a metal oxide varistor or MOV that diverts excess voltage to ground. Arc fault circuit interrupters, or GFCIs, are designed to protect against arc faults. Arc faults are dangerous electrical arcs that can occur when wires are damaged or connections are loose. These arcs can generate heat and ignite nearby materials, leading to a fire. GFCIs are typically installed in bedrooms and other areas where arc faults are more likely to occur. Grounding is another important aspect of electrical safety. Grounding provides a safe path for electricity to flow in the event of a ground fault. All electrical outlets and appliances should be properly grounded. The grounding wire is typically a bare copper wire or a green insulated wire. The grounding wire should be connected to a grounding electrode, such as a ground rod or a metal water pipe. In summary, electrical safety is a critical aspect of home ownership. By installing GFCIs, circuit breakers, fuses, surge protectors, and GFCIs, and by ensuring proper grounding, individuals can create a safer living environment for themselves and their families. Remember to consult with a qualified electrician if you have any questions about electrical safety. Let's consider a few more points about the refrigerator exception. While it's generally not recommended to put a refrigerator on a GFCI circuit due to the risk of nuisance tripping, there are some situations where it might be considered. For instance, if the refrigerator is located in a damp or wet area, such as an unfinished basement, a GFCI might be required by local codes. In such cases, it's important to use a high-quality GFCI and to be aware that occasional tripping might occur. Another option is to use a GFCI circuit breaker instead of a GFCI outlet. GFCI circuit breakers are designed to be less prone to nuisance tripping than GFCI outlets. However, they are also more expensive. If you are considering using a GFCI for a refrigerator circuit, it's best to consult with a qualified electrician to determine the best approach. The electrician can assess the specific circumstances and recommend the most appropriate solution. It's also worth noting that some newer refrigerators are designed to work with GFCI circuits. These refrigerators have features that minimize the risk of nuisance tripping. If you are purchasing a new refrigerator, it's a good idea to check whether it is compatible with GFCI circuits. In addition to refrigerators, there are other appliances that may not be suitable for GFCI protection. These appliances include freezers, sump pumps, and other devices that require a constant and uninterrupted power supply. Nuisance tripping of a GFCI can cause these appliances to malfunction or fail, which can lead to significant problems. For example, if a freezer trips off, the food inside can spoil. If a sump pump trips off, the basement can flood. Therefore, it's important to carefully consider the potential consequences of GFCI protection before installing it on any appliance. In general, it's best to consult with a qualified electrician to determine the best approach for protecting electrical circuits in a home. The electrician can assess the specific circumstances and recommend the most appropriate solutions. Electrical safety is a complex and multifaceted topic. It's important to stay informed about the latest codes and best practices. By taking the necessary precautions, individuals can create a safer living environment for themselves and their families. It is also important to note that GFCIs do have a limited lifespan. Over time, the internal components of a GFCI can degrade, which can affect its performance. It is generally recommended to replace GFCIs every 10 to 15 years, or sooner if they are frequently tripped or if they show signs of damage. Replacing GFCIs is a relatively simple and inexpensive task that can help to ensure continued electrical safety. When replacing a GFCI, it's important to choose a model that is compatible with the existing wiring. The GFCI will have terminals for the hot, neutral, and ground wires. It is important to connect the wires to the correct terminals to ensure that the GFCI functions properly. If you are not sure how to connect the wires, it's best to consult with a qualified electrician. After replacing a GFCI, it is important to test it to ensure that it is functioning properly. To test a GFCI, press the test button on the device. The GFCI should trip, indicating that it is working correctly. If the GFCI does not trip when the test button is pressed, it should be replaced again. Regular testing and replacement of GFCIs are essential for maintaining electrical safety in a home.